In this video, we're going to take a look at finding the determinant of 3x3 matrices. Now, in the previous video, we saw how to find the determinant of a 2x2 matrix, and we saw that the method was quite straightforward, quite nice and easy. In this video, for the 3x3 determinant, it's a little bit more involved, there's a bit more work to it, but hopefully you shouldn't find this too challenging. So, we've got two examples here that we're going to work through together, and then on the next page there's a problem question for you to have a go at. So before we can find these determinants though, we need a special matrix. And this matrix tells us which of the elements will be positive and which will be negative. So in the top left, we always start with a positive element, so plus, and then it just alternates between positive and negative. So minus, plus, minus, and so on. So I'll just jot these down dead quick. Okay, just double check they're okay. Yeah, perfect. Now we do need this, it's not random, so I'd always jot this down. Whenever you find the determinant of a 3x3 matrix, I would always write this down just to be aware. So if we start with this matrix A first and find the determinant of the matrix A, then what we do here is there's actually a few different routes you can take to find this determinant. Now, we find the determinant by expanding along a row or a column, and it doesn't actually matter which row or which column you pick, you should get the same answer no matter the row or column. But sometimes you might find it easier to go along a certain row or a certain column. So what I'm going to do for this first example is I'm just going to expand along the top row. That is generally the row I always pick. And then I'm also going to expand along the middle column. And you'll see why when we come to that, the middle column is actually the easiest for this example. So if we start with the top row then, so for det A here, then along the top row, we've got our top left element, this one. Okay, this is the first element in this row, working left to right. Now this one here, using this matrix here, which tells us whether it's going to be positive or negative, that tells us that the one will be positive. So we just jot this one down, okay? And this is what we're going to multiply once we cross this row off and this column. So we get rid of the row and the column that contains this element. And what you get left with is a 2x2 matrix. And what I need to do now is find the determinant of that 2x2 matrix. So 3, 2, 0, and 1. And this one here tells us what we multiply the determinant by, okay? Now, I'm not going to work out the determinant just yet. What we'll do is we'll expand the full row, and then we'll come back and evaluate everything at the very end. So let's just cross that off. Let's go along to the next element. Well, this is 0. So that would be minus 0 and then the 2x2 determinant. But obviously, it doesn't matter what that determinant is. Once I times it by 0, it will just be 0. Okay, so we can just skip that element. And then we move along to the last one here. So this is 2. So it's going to be positive again using this matrix here. So we write plus 2. And then we need to find the 2x2 determinant. So we cross off this row and this column. And I get left with 0, 3, 1, 0. So 0, 3, 1, 0. And now we just need to evaluate these 2x2 determinants, times them by essentially the coefficient in front, and then just simplify everything. So 3 times 1 is 3, minus 0 times 2. So I'm just going to get 3 there. So 1 lot of 3 giving me 3. And here then we've got 2 lots of the determinant. So it's going to be 0 times 0, which is 0, minus 1 times by 3. Okay, so I'm going to get minus 3 there. So we get 2 lots of minus 3. So 2 lots of minus 3, which is minus 6. So we get minus 6 plus 3, giving me minus 3 there. Okay, so for the first determinant, for the matrix A, we get minus 3. Now what I'm also going to show you here is expanding along the middle column. Okay, so let's just get rid of that. So if we expand along the middle column, the reason why this is nice and straightforward is basically because we've got so many zeros. This element here is 0. This bottom element here is 0 along this column. So the only one I'm actually concerned about is this middle element here, this 3. So it's negative, positive, so we get 3 lots. So for the A again. So we get 3 lots. We cross off this row because that's the row that the 3's on, and it's this column. Okay, and we get left with 1, 2, 1, 1. So 1, 2, 1, 1. So we need to find the determinant of this 2x2 matrix, times it by 3. And what we should find here is we get the exact same as what we got for the top row. So we should get minus 3 again. So what I'm going to get here is 3 lots. I'm going to do 1 times by 1, which is 1. And then we do minus 1 times by 2, which is 2. Or minus 2, sorry. So 1 times 1 is 1. And then we minus 1 times 2, so minus 2 there. Okay. So 3 lots of 1 minus 2, so that's 3 lots of minus 1, giving me minus 3 there. Okay, so for the determinant of A, again, we got minus 3. Perfect, that's exactly what we got when we expanded along the top row. So you can always do that as another check if you really want. In an exam, you're probably too tight for time to actually do that, but it is an option if you'd like to check. Okay, so like I said, doesn't matter which row, which column you pick, you should get the same answer no matter which row or column. So that's the first example. It took quite a while to get through, but hopefully the method is quite clear now as to how we do this. Let's take a look at one more example, and then there's a practice question for you to have a look at. So we've already got our matrix here denoting which elements are positive, which are negative. Now again, I'm just going to go along the top row here. So for det B, going along the top row, well, my top left element is 1, and that's positive, so we just write 1 here. We now cross off this row and this column, and I get left with 3, 1, 2, 0. So 3, 1, 2, 0. Okay. We then go along to the next element, so let's just get rid of those lines again. So that's a 0, so we can just skip that because it doesn't matter what the determinant is. Once you times it by 0, it will also be 0. And we've got this 4 here in the top right corner, so that will be positive using this matrix here. So we write plus 4. We cross off this row and this column, and I get left with 0, 3, minus 1, 2. So 0, 3, minus 1, and 2. So all we need to do now is evaluate the individual determinants, times them again by their, essentially their coefficients, and just simplify. So 3 times 0 is 0, minus 1 times 2, so that would give me minus 2 there. So I get one lot of minus 2, or in other words, just minus 2. We then need to calculate this 2 by 2 determinant, so 0 times by 2 would be 0, and then we do minus 1 times 3, so that would be plus 3, so I get 4 lots of 3 there. So 4 lots of 3 is 12, minus the 2, this would give us 10 there. So det B is equal to 10. Again, you could go along a different row or a different column if you wanted to double check this, but you should find you also get 10 again. Okay. So that were a couple of examples that we've worked through. Now it's your turn to have a quick go at finding the determinant of the matrix C. Like always, pause the video now, have a quick go, and then we'll take a look in a moment at what you should get. So for this matrix here, for the matrix C, to start with, we need our plus negative matrix. So put that in the bottom right. So plus, minus, plus, and so on. There we go. Doesn't look particularly neat, but we just need to know which elements are positive, which are negative. So for det C then, we now need to choose which row or column we're going to go along. Again, it's completely up to you. Let's just go along the top row here. Okay, so again, I'm just going to go along the top row. If you really wanted, you could go across, say, the middle row here, because you've got the 0. In fact, let's just do that. Let's just go along the middle row. I'm going to be a bit lazy. Okay, I want to get a 0 element here. So this middle element, or this middle row, the first element will be negative by looking at this matrix. So that's going to be minus 3. Okay, so minus 3. So we cross off this row and this column, and I get left with 1, minus 2, minus 1, 0. So 1, minus 2, minus 1, 0. So let's just go along again. Clear the line so we can see. So the next element is 0. So that will just be 0 once we multiply it by its 2 by 2 determinant. So we don't need to worry about that. And then the last one here is 4. But again, this will be negative. So it's going to be minus 4. We cross off this row that the 4 belongs on and this column where again the 4 belongs on. And I get left with 2, 1, 1, minus 1. Okay. So all we need to do now is evaluate the individual 2 by 2 determinants, times them by those coefficients, and then just simplify it. So hopefully I won't make a mistake with my signs here. It's really easy to do that. So 1 times 0 is 0, minus minus 2 times minus 1. So that would be positive 2, but we're taking the minus of that. So I'm going to get minus 3 lots of minus 2. So that looks good. We've then got minus 4 lots of, so let's work this out. 2 times minus 1 is minus 2 minus 1 times 1. So that's going to give me minus 3. So I get minus 4 lots of minus 3. And we simplify this here. Minus 3 times minus 2 is 6. Minus 4 times minus 3 is 12. So I get 6 plus 12, giving me 18 there for the determinant of C. So det C is equal to 18. And again, you could pick a different row, different column. You've got to double check that. And you should get the same answer here. So you should also get 18. Now, 2 quick points to make here before we finish this video. Just like we saw for a 2x2 matrix, if the determinant of a 3x3 matrix is equal to 0, again, we say this is a singular matrix. If the determinant of C is not equal to 0, then we say this is a non-singular matrix. Okay. And another point is most graphical calculators will actually find the determinant of a 2x2 matrix and a 3x3 matrix on the calculator. So that only holds really for matrices that are completely numbers. If you've got algebraic elements, then that won't be true. And what you'll often find is on a lot of the exam papers, it is a matrix that involves algebraic elements. So you can't just put it into your calculator. So do make sure you know how to do this by hand. Obviously, if you get a matrix that's just numbers only, then nice and straightforward, you can just put that into your calculator, okay? But there we have it. So that brings us to the end of this video. In the next video, we're going to take a look at finding the inverse of a 2x2 matrix.